Hi there, this is Jacob Nash, Engineering Lessons. In this video, we're going to be talking about fluid power. So this is Unit 3.2, Lesson 1. And there's a lot more notes provided by PLTW, but I'm just going through the basics that you'll need to know to solve for your problems. So, what is fluid power? It's the use of fluid to transmit power from one location to another. So, it's basically you're utilizing the fluid and you can transmit power. It's kind of straightforward. And then hydraulics is the use of flowing liquid under pressure to transmit power. And pneumatics, you don't say pneumatics. That's like pneumonia, no P. You use gas under pressure to transmit power. So this is something important in engineering because we can use this, and this kind of ties in with the energy unit we did, which was 1.2. So in this picture that I, in fact, took, would that be hydraulics or pneumatics? Well, it would be hydraulics because it's water there. That's the Savannah River at the border between South Carolina and Georgia. And not pneumatics because that's not gas. That's just a river. So, now I don't know if they actually use that water for energy, but if they did, it would be hydraulics. So we have three laws to talk about, and these usually with a law comes an equation that we can use to solve problems in our activity that's coming up. So Charles's law says when pressure on a sample of dry grass is held constant, the temperature of the volume will be in direct proportion. So it's saying that if it's constant, the temperature and volume will increase in proportion with each other. So that means that volume 1 divided by temperature 1 equals volume 2 divided by temperature 2. So in an equation, when you're given values, you can plug in, find them. So V is volume and T is temperature, but it's absolute temperature. So we'll talk more about this in the next lesson, but that means it's not just Fahrenheit. It has to be in degrees Rankine if it's going to be absolute, and it has to be absolute for the equation to work. So that means you have to add 460 to the temperature in Fahrenheit. So if we had 5 degrees Fahrenheit, to plug into this equation, we would need to make it 465 because we add 460. So Gay-Lussac's law, I think that's how you say it, Lussac, this states the pressure of a given mass varies directly with the absolute temperature of the gas when the volume is kept constant. Temperature also illustrates the direct relationship. Basically, this is saying, just like with Charles's law, the pressure will increase as temperature does. So, that's, you see the equation there, pressure 1 divided by temperature 1 equals pressure 2 divided by temperature 2. And like in the last equation, temperature has to be absolute, so add 460, but the pressure has to be absolute too, so you have to add 14.7 to a pressure to make it absolute, and that will be in PSI. Both are in PSI, but one is absolute and one is not. In Boyle's law, it says the direct pressure of a given quantity of gas varies inversely with the volume. So this time they're not constant. They are inverse to each other. So pressure 1 times volume 1 equals pressure 2 times volume 2. P is absolute pressure, so once again you have to add 14.7. So anytime you see P in an equation, you need to add 14.7, and anytime you see T, add 460. And V is volume as usual, but yeah, you don't have to do anything to that. Sometimes certain cases, we'll talk more about this in the next lesson as well, you'll have to convert from gallons per minute to inches cubed per minute, and vice versa. So let's pretend that to convert to gallons per minute, we'll represent that with G, and inches cubed per minute is I. So these are the two equations. To convert to gallons per minute, divide the inches per minute by 231. To convert to inches per minute, multiply it by 231, the gallons per minute. So that's what you can do. And then let's have a quick reminder about mechanical advantage. It's the output force divided by the input force. So let's say there was a input force of 2 and an output force of 8. So we started with 2 pounds of force. After going through the fluid power occurrence, we get 8 pounds of force. To find the mechanical advantage, we do 8 divided by 2, and we would get 4. And there's no units for that, but we'll talk more about that in the next video. So that would be it for this video. Thanks for watching, and in the next lesson, we'll go over some problems from activity 3.2. I think it's just 3.2. I don't know though. Let me see here. 3.2.3. That's what it is. Sorry. And we'll have our final unit that I'll go through, which is unit 4.1 and 4.2. So that will be it. Thanks for watching.